Hello, good day to you all. You are welcome to Blenius Serious College class. And the question that we have here is from moment generating function. We are to obtain the moment generating function of gamma attribution. And the first thing I want to state here is the PDF for the gamma attribution, where we have beta raised power alpha, x raised power alpha minus 1, exponential minus beta x, everything over gamma alpha. So now here x is greater than 0, alpha is greater than 0, then beta is greater than 0. So this one is under continuous random variable. So this is the probability density function for the gamma distribution. So now to obtain the moment generating function, so the moment generating function for a continuous random variable x is defined as that's integral minus infinity to infinity exponential tx f of x dx. So this is the moment generating function for a continuous random variable x is defined as this. So now ms of t is equals to what we have here. So we have integral, so s start from 0 to infinity, so s is greater than 0. So we have exponential tx. So now the PDF f of s is given as this, so that's beta raised power alpha, x raised power alpha minus 1 exponential minus beta x over gamma alpha. Here we have the x at the back. So now this beta raised power alpha and this gamma alpha, they are constants. Then we can factor that one out. So you're going to have beta raised power alpha over gamma alpha integral infinity to 0. So we're going to have x raised power alpha minus 1 exponential tx times exponential minus beta x. Here we have the x. So now from what we have here, beta raised power alpha is a constant, we'll factor that one out. Gamma alpha also is a constant, and we'll factor that one out as well. So we can write this x raised power alpha minus 1 first, then this exponential tx and exponential minus beta x, so we can bring the two together. So now from what we have here, they have the same base, so that's exponential. So that means from here we can use the law of indices so that we sum the powers together. So that will be exponential tx plus minus beta x. Here we have the x. So now we're going to add the powers together. So the exponent ts plus minus beta x. So now this will give us beta raised power of alpha over gamma alpha integral 0 to infinity x raised power alpha minus 1 exponential tx minus beta x dx. So that's what we're going to have from there. So now we can also rewrite it as this. So from what we have there, so we have equals to beta raised power alpha over gamma alpha integral 0 to infinity. So here we have x raised power alpha minus 1 exponential minus beta minus t x dx. So now what we have here, exponential ts minus beta s. So we can rewrite it as minus then beta minus t, then x is outside there. So by the time we expand this, exponential minus beta minus t, x is outside there. We use this x to expand it. So that will give us exponential, negative is t here. So this one will be called beta x minus tx. So later on, by the time we use the negative sign to expand it, that will be minus beta x plus tx, which is known as exponential tx minus beta x. So what we have here can also be written as minus into beta minus t, then x is outside there, so that we can make use of gamma function. So we want to turn it to a gamma function, or we can as well integrate it directly from there. So now we can make this one equation 1. Then we can say let y, so we can represent beta minus t x with letter y, that's equation 2. So y is equals to beta minus t, then x is outside there. So that means from here we can divide both sides by beta minus t so that we can obtain the value of x. So this implies that x is equals to y over beta minus t. So now from what we have here, so we can make this one equation 3. So we can say dx is equals to the y over beta minus t. So here we have dx is equals to the y over beta minus t. So we can make this one equation 4. Now we'll substitute equation 2, 3, and 4 into equation 1. So we are substituting equations 2, 3, and 4 into equation 1. And from equation 1, we have ms of t is equals to expected value of exponential tx is equals to, that's beta raised power alpha over gamma alpha. So beta raised power alpha over gamma alpha, the integral 0 to infinity x raised power alpha minus 1 exponential minus open bracket beta minus t x dx. So now in this case, we have beta raised power alpha over gamma alpha integral 0 to infinity. So instead of writing x, don't forget that the value of x is equals to y over beta minus t. So we are going to have y over beta minus t. Then the power of x here is alpha minus 1 exponential minus y. Instead of writing beta minus t, then x. So don't forget that when you go back to equation 2, we actually use y to represent beta minus tx. So now here we're going to have, instead of writing the x, that will become dy. So this one will be dy over beta minus t. So that's it. So now from what we have there, we can have this. So this, we have ms of t is equals to beta raised power alpha over gamma alpha. Now we have integral 0 to infinity. Then don't forget that this y and beta minus t, they are both sharing the same power. That means we have y raised power alpha minus 1 over beta minus t raised power alpha minus 1. So from what we have here, so they are both sharing the power. Now here we have exponential minus y, then dy over beta minus t. So now this one is a constant, we'll factor it out. Then this one as well is also a constant, we'll factor them out. So here we're going to have beta raised power alpha over gamma alpha times 1 over beta minus t raised power alpha minus 1 times 1 over beta minus t. So this one is what we have here, because it's actually at the down part at the denominator. That's why we're having 1 over beta minus t, everything is power alpha minus 1 times this one also is actually at the down part. So that's why we're having 1 over beta minus t as well. So this integral sign is here, 0 to infinity y raised power alpha minus 1 exponential minus y dy. So now let's start from this particular side. So this and this, they have the same base. So since they have the same base under the law of indices, so using the law of these indices, that means we have beta minus t raised power alpha minus 1 times beta minus t. The power of that one is 1. Since they have the same base, that means we are writing beta minus t raised power alpha minus 1 plus 1, the power of this one. So this will cancel this. So that means we are going to have beta minus t raised power alpha. So that's what we are going to have from there. So that means we have beta raised power alpha over gamma alpha times 1 over beta minus t raised power alpha times integral 0 to infinity y raised power minus 1 exponential minus y dy. So now the next thing we're going to do here is, don't forget what we have here is a gamma function. Everything that is here is a gamma function, because the power of the exponential is negative as well. So that's a gamma function. So now note that integral 0 to infinity y raised power minus 1 exponential minus y dy is equals to, the power of this y is alpha minus 1. That will be alpha minus 1 plus 1. So we add 1 to it. So this is a gamma function. So that will be gamma alpha minus 1 plus 1. So that's how we evaluate that. So this will cancel this one. So that means we have gamma alpha. So everything that is here is equals to gamma alpha. So therefore, mx of t is equals to beta raised power alpha over gamma alpha times 1 over beta minus t raised power alpha times gamma alpha, because everything that is here actually gives us gamma alpha. So now kindly note that this will cancel this. So now the final result that we have here is, that's beta raised power alpha over beta minus t raised power of alpha. So which can also be written as So we can say therefore the moment generating function for gamma distribution is, since alpha is common to their power, so we have alpha here and the power of that one is also alpha, we can write it as beta minus c, everything is power of alpha. So like this, or from what we have here, we can write it as beta raised power alpha in brackets beta minus t raised power negative alpha. So what we have here can be written as this, or it can also be written as what